let's solve chapter 6, E1. A horizontally directed force of 40 Newton is used to pull a box a distance of 2.5 meters. D, this is F, right? Across the tabletop. And how much work is done by the 40 Newton force? Okay, work equal F times D. F equal 40 Newton. D equal 2.5 meters. So 100 joule as your work. Okay. The next one is chapter 6 E2. A woman does 160 joule of work to move a table 4 meters across the floor. What is magnitude of force that woman applied to a table if this force is applied in horizontal direction? Work equal FD, and then work is 160 joule, and then F you don't know yet, but distance is 4 meters. Then F supposed to be 40 Newton. Okay. The next question should be E3. A force of 60 Newton as F used to push the chair across the room with does 300 joule of work, and how far does the chair move in this process? Work equal FD, and the work is given 300 joule. Force is given 60 Newton times D, and D equal 5 meters after you divide. Okay, the next one, E4. A rope applies a horizontal force of 180 Newton and to pull a crate a distance of 2 meters and across the floor. Friction force is 60 Newton opposite this motion. What is the work done by this force? The force applied by the loop. Okay, so is F1 180 Newton. On the floor there is a friction. F friction equal 60 Newton opposite direction. So you need to find F net equal F1 plus F friction, and 180 Newton minus 60 Newton becoming 120 Newton. So work equal F net times D. So F net is 120 Newton, distance is 2 meters, and 240 joule as your work. Then what is work done by the friction? This one, F net, is given as C, answer C, and answer A, work equal F1 times D. Then you will get 180 Newton, 2 meters, then 360 joule for the force by the force. And what is work done by the friction? Okay, work is F friction times D, negative 6 Newton times 2 meters, then negative 120 joule. Then this is work by friction, this is work by force. Okay, then work total supposed to be work friction plus work by force plus work friction. Then 360 joule, negative 120 joule to 40 joule should be your total work done by this. Okay, the next question is a force of 50 Newton is used to drag the cradle 4 meters across the floor. The force is directed at the angle upward on the cradle so that the vertical component of the force is 30 Newton and the horizontal component is 40 Newton. Okay, what is work done by horizontal component of the force? So F horizontal and F vertical, and the distance, this is the total force. Okay, and the work horizontal supposed to be F horizontal times the distance. F horizontal is 40 Newton, distance is 4 meters, and 160 joule. What is work done by the vertical component of the force? Work vertical equal F vertical times the distance vertical. Then the distance vertical is become 0, nothing moved in vertical way. So 30 Newton as vertical force times 0 meter, then 0 joule. Okay, total work done by the 50 Newton, and the total becoming horizontal plus vertical. So 160 joule plus 0 joule becoming 160 joule. Okay. Okay, the next one is a net force of 60 Newton accelerates 4 kilogram mass over distance of 10 meter. And what is the work done by this net force? Okay, so work equal FD, and F equals 60 Newton, D equal 10 meter, and 600 joule is work. And what is the increase in the kinetic energy of this mass? Okay, the work equal kinetic energy increase. So work KE increase equal 600 joule after the distance travel. Okay. Okay, the next question is E7 on chapter 6. 0.4 kilogram ball has velocity of 20 meters, and what is the kinetic energy? And then kinetic energy is supposed to be half mv squared. So half times 0.4 kilogram. This is mass. This is velocity. 20 meters per second square. Then 0.22 times 20 square equal 80 joule. It's kinetic energy. And how much work would be required to stop the ball? So kinetic energy equal the work to stop. So kinetic energy 80 joule means work to stop is 80 joule, but negative direction. Okay, you need to subtract the 80 joule from a baseball, from the ball, then you can get this stop. Okay, the next one is E8. A box with a mass of 5 kilogram is lifted without acceleration through a height of 2 meters in order to place it upon the shelf of a closet. What is the increase of potential energy of the box? potential energy by gravity is mgh, or this h means the height. So m equal 5 kilogram, g equal 9.8 meter per second square, and the height is 2 meter, and 98 joule. Then how much work was required to lift the box to this position? Okay, the potential energy increase equal as work done on the box. So 98 joule of work should be done on the box. Okay, the next one is E9 on chapter 6, and a spring with a spring constant K of 40 Newton per meter stretched a distance of 20 centimeter from the original unstretched point. What is the increase in potential energy of the spring? Potential energy of the spring equal half k x square. K is here, and then x is 0.2 meter. Half times 40 Newton per meter, 0.2 meter square. Then 0.2 square times 20. Then it should be 0.8 joule. Okay, the next one is to stretch a spring a distance of x distance of 0.2 meter. 40 joule of work is done. And then what is increased potential energy of the spring? Okay, potential energy of spring increase is equal as work done on the spring. So 40 joule of potential energy of spring will be increased. Okay, what is the value of spring constant K? Potential energy of spring equal half kx square. So potential energy is supposed to be 40 joule equal as half times k times 0.2 meter square. Then 0.2 square times 0.502, and then 40 divided by 0.02. Then K equal 2000 Newton per meter, which is your spring constant. Okay. E11. So, which required more work? Lifting 2 kilogram rock to height of 4 meter. 2 kilogram rock, height of 4 meter without acceleration, or accelerating same rock horizontally from rest to a speed of 10 meter per sec. Okay. So this potential energy by the gravity equal mgh. So m is 2 kilogram, g equal 9.8 meter per second square, h equal 4 meter. Then 9.8 times 8, 79.4 joule, 78.4 joule, 8.4 joule. And then the other one is F equal speed raised to speed of 10 meter per second, and the kinetic energy to get 10 meter per second is half mv square. Half times 2 kilogram times v equal 10 meter per sec square. Then 100 joule. So in this case, the accelerating same log horizontally from rest to speed 10 meter per second is 100 joule needed to require, so it has more work done on the accelerating the log. Okay, the next question is E12. At the low point in its swing, the pendulum bob with a mass of 0.2 kilogram and the velocity is 4 meter per second. So what is its kinetic energy at the lowest point? Okay, so half kinetic energy is max on the lowest point, max mv square. So half times 0.2 kilogram times 4 meter per sec square. Okay, 16 times 0.1 coming 1.6 joule is kinetic energy. And ignoring air resistance, and how high will the bob swing above the low point before reversing the direction, which means kinetic energy max equal as potential energy max at the point, so which is mgh. So potential energy max supposed to be 1.6 joule, m equal 0.2 kilogram, and this supposed to be g is 9.8 meter per second square. H you need to find it. Okay, 1.6 divided by 0.2 divided by 9.8, then you will get H as 0.816 meter. Okay, the next question is E13. A 0.2 kilogram mass attached to the spring is pulled back horizontally across the table so that the potential energy of the system is increased from 0 to 120 joule. Okay, and ignoring friction, what is kinetic energy of the system after the mass is released and has moved to a point where the potential energy has decreased to 60. Okay, first spring there, and then is pressed, right? Pulled back horizontal and increased. Like this, push, and then it used to be potential energy is 0, and then pull back in a certain point, potential energy becoming 120 joule. Then, which means increase and release it, and then in certain point becoming potential energy becoming 80 joule. Later it's release, certain point potential energy equal 80 joule, then kinetic energy of that time. Okay, that is the question. So mechanical energy equal potential energy by the spring plus kinetic energy is constant. which is we call as energy conservation, right? Potential energy supposed to be at the original point, which is PE equal 120, and then it was stopped, which means 120 joule plus 0 joule, which is 120 joule altogether. And the next point, ME2, this is first, is potential energy supposed to be 80 joule plus kinetic energy becoming 120 joule as well. So kinetic energy is supposed to be 40 joule at that moment. Okay, the next question is E14. A sled and ride with a combined mass of 50 kg are at the top of the hill, height of 15 meters above the level of ground. The sled is given a push, providing an initial kinetic energy. The top of the hill is 1600 joule. And choosing reference level at the bottom of the hill, what is the potential energy of the sled and the riders at the top of the hill? So H equal 15 meter and M equal 50 kilogram. So potential energy of the top equal mgh. M equal 50 kilogram, G equal 9.8 meter per second square, and then H 15 meter. Then 50 times 9.8 times 15 equal 7,350 joule at the top. After push, what is total mechanical energy of the sled right at the top of the hill? So mechanical energy equal potential energy by gravity plus kinetic energy. So mechanical energy by gravity at the top is 7,350 joule plus kinetic energy is 1600 joule. Then plus 1600, then you will get 8,950 joule altogether. And if the friction can be ignored, what is the kinetic energy at the sled and the rider at the top, at the bottom of the hill? Okay, then mechanical energy of bottom equal potential energy of ground gravity on the bottom plus KE. So potential energy on the bottom means there is no potential energy by gravity, equal as 8,950. So kinetic energy is supposed to be 8,950 joule. Okay, the next question is the E15. A roller coaster car has potential energy of 4450,000 joule. Its kinetic energy of 120,000 joule at point A in its travel. At the low point of a rider, and the potential energy is 0, and 50,000 joule of work has been done against friction since it's left point A. And what is the kinetic energy of the roller coaster at this low point? Okay, so mechanical energy of the point A equal kinetic energy point A plus potential energy by gravity point A. So kinetic energy is 120,000 joule plus potential energy is 450,000 joule. Then 570,000 joule is mechanical energy total on point A. And the mechanical energy point B or bottom equal kinetic energy of A plus potential energy of gravity by gravity A, kinetic energy of point B, and the potential energy on the B, plus work by friction, but supposed to be it's negative. Okay, then potential energy on the ground bottom supposed to be 0. Then kinetic energy you don't know, and this is supposed to be 570,000 joule. So KEB minus 50,000 joule. Supposed to be this is a positive, equal 570,000 joule. So kinetic energy and the bottom supposed to be 520,000 joule. Okay. The next question is 16. A roller coaster car with a mass of 1,200 kilograms starts at last from the point 20 meters above the ground. At point B, it is 12 meters above the ground. What is initial potential energy of the car? Potential energy point A equal mgh point A, which is 1200 kilogram, 9.8 meter per second square. H equal 20 meter. Then 1200 times 9.8 times 20. Then 235,200 joule. And what is potential energy at the point B? Potential energy point B equal mgHb. So 1200 kilogram and 9.8 meter per second square and 12 meter. Then 1200 times 9.8 times 12. Then 141120 joule. And if initial kinetic energy was 0 and the work done against the friction between the starting point to point B is 330,000 joule, what is the kinetic energy of the car at point B? Okay, so mechanical energy equal PEA plus K kinetic energy A. This is 0, right? Which is 235200 joule equal as potential energy of B plus kinetic energy on B plus work done by the friction. So potential energy on the B equal as 141120 joule plus kinetic energy B plus work 30,000 joule. So KEB, you subtract this from this, right? 235,200 minus 41120 minus 30000. Then you will get 64,000 64,080 joule, which is your kinetic energy at point B. Okay. The next question is E17. 200 grams of mass lying on frictionless table is attached to horizontal spring with a spring constant of 400 Newton meter and spring stretch a distance of 0.4 meter. And what is initial potential energy of the system? Potential energy by the spring is half kx squared. Then half times k is 400 Newton per meter times 0.4 meter square. 0.4 square times 200. Then you got 32 joule. And what is kinetic energy of the system when the mass is returned to equilibrium position after being released? Mechanical energy equal kinetic energy plus potential energy of spring, which is a constant, which is 32 joule. This is at equilibrium. Then this supposed to be equilibrium. There is no increase of spring or decrease of spring, so there is supposed to be 0 as a distance. Okay? Which means there is no potential energy at equilibrium position. So KE equals whole mechanical energy because of no friction, which is 32 joule. This is your answer. Okay, the next one is E18. The time required for one complete cycle of mass oscillating end of spring is 0.25. What is frequency of oscillation? Okay, t equals 0.25 second, and frequency equal 1 over t. So 1 over 0.25 second, 4 hertz, the frequency. Next one is the frequency of oscillation for the pendulum is 8 cycles per second. What is the period? Frequency equal 8 hertz. Then t equal 1 over f. So 1 divided by 8 hertz become divided by 8, 0.125 second is your answer for number 19. Okay, this is all for chapter 6 answers. So okay, thank you and bye now.